Ujung sikit. Okay, untuk makluman our paper final exam date on 15 March 9 AM. 15 March. Okay, now kita tengok chapter 6, one way ANOVA. Okay, first we go to general ANOVA setting. What is ANOVA? ANOVA is analysis of variant. Abbreviation is ANOVA lah. So dia kata investigator control one or more factor of interest. We control one or more. Tapi in our case, we only focus on one factor of interest. That's ANOVA, one factor. Each factor contains two or more levels. Okay, level can be numerical or categorical. So different level produce a different group. Think of each group as a sample from a different population. These are assumptions under ANOVA. So ANOVA first, only one factor. Under factor, we have more than two groups. It's a group. For each group ni, dia ada level lah. It's one factor. So if more than one, maybe they have another factor here. Factor yang effect ni, group ni, that's ANOVA. So observe effect on the dependent variable. So nilai observe ni, nilai ni, effect on dependent variable. Dia kan? Effect on dependent variable. Experimental design, one example untuk ANOVA. ANOVA kita selalu pakai untuk experimental design. The plan used to collect the data. Then to collect the data, okay. Completely randomized design. ANOVA ni dia under randomized design. Experimental unit are assigned randomly to group. Setiap group kita ambil secara random. And the subject are assumed homogeneous, maksudnya sama. Kalau first group tu student, second group, third group, and so on mesti student. Bukannya first group you ambil student, the second group you ambil lecturer, third group you ambil management staff tak boleh or clerk tak boleh. Dia mesti sama, homogeneous Only one factor or independent variable with two or more level. Analyze by one factor, analysis of variant. Nama dia ANOVA. Analysis of variant one factor. Kita panggil one way ANOVA. One way maksudnya kita fokus only one factor as an independent variable. Right? To predict one dependent variable. Di mana setiap nilai yang kita measure untuk dalam group tu akan contribute kepada dependent variable. So kita tengok example. So one way analysis of variant ataupun one way ANOVA evaluate the different among the mean of a three or more group. Kita nak compare mean more than two groups. Kalau two group kita tak pakai ANOVA, kita pakai t-test More than two group. Okay. Dan kita assume sample draw from the same population. Yeah. So given example, this example, accident rate for first, second and third shift. Expected mileage for 5 brand of tire. So kita boleh kelaskan kepada two different variable. Accident rate is dependent variable. Dependent variable yang dia depend dengan orang lain. Dia tak boleh duduk sendiri. Okay. Variable yang terjadi disebabkan oleh variable lain. Okay. So accident rate kat sini dia tengok on the factor apa? Tire. Mungkin tire ni contribute kepada accident rate. So tire as an independent variable. So what is the factor? expected mileage lah. Okay. Tayar ni dia tengok faktor dia, attribute dia, expected mileage. Itu sebenarnya, itu adalah faktor, itu adalah factor. This is a sample or group. And then this is a dependent variable. Okay. Ada yang buku dia buat dependent. Pergi kepada factor. Factor. Kemudian dia tengok independent. Independent ni dia collect daripada sample lah. Sample 1, sample 2, sample 3 and sample 4 and so on. Okay. Itu adalah one-way ANOVA. Kenapa nama dia one-way ANOVA? One-way ANOVA maksudnya only one factor. We focus only one factor. Kalau ada interaction, more than one, kita panggil one-way. Kita panggil two-way ANOVA. Ataupun multivariate ANOVA. Dia banyak, ANOVA ni banyak. ANOVA, MANOVA, ANCOVA, macam jenis. You all tengok ANOVA je dulu. So, this is assumption kalau you construct ANOVA. First, assumption, population must be normal distributed. Kena normal. Kemudian population tu equal variant. And then sample random. Dan independent. Dia ambil daripada populasi tu secara random dan independent. Okay. And then baru you boleh construct ANOVA. So this is a hypothesis of one-way ANOVA. One-way ANOVA only one type of hypothesis, because one-way ANOVA we more interest on the differences between mean, because we assume that mean are equal or sample draw from the same population. This is hypothesis. Hypothesis dia sama je, equal and not equal, because differences. You are more interested on differences. So H9 mean equal. H1 alternative, not all of the population mean are the same, or at least one mean are not equal. Ataupun difference. Okay. Okay. So ANOVA ada hypothesis satu saja, one type. This is a type. What is C? C is number of group. Group yang kita test dalam ANOVA, number of group. That is C. Okay, this is mean. Okay, one-way ANOVA. Mean for hypothesis. H now you assume that all mean are equal. H1 at least one mean are not same. So the null hypothesis, there's no factor effects. Sama je. Semua mean sama saja. Sample 1, sample 2. Kat sini dia bagi 3 sample. 1, 2, 3. Semua sama. Okay. So for alternative, this is for alternative. At least one of the mean is different. At least one. So this example, mu1 and mu2 equal, but mu3 not equal. Or mu1, mu2 or mu3 all are not equal. This hypothesis alternative. Partitioning the variation, sebab ANOVA dia tengok variation, variance among and within group, because kita test on difference. Different of a sample yang kita draw from the same population. Sebab tu dia tengok on variation ANOVA ni. Dia nak tengok perbezaan. Okay. So dia ada total variation, SST, sum SS is sum of square. SS. Sum of square SSA among group, SSW within group. What is this among group? Okay. Among group ni di antara group. Okay. Contoh dia ada mu1, mu2, mu3, mu6. So the test different. mu1, mu2, mu1, mu3. And then mu2, mu3. The test on difference. So within group, the test, the variation within the group. Okay. Example, group 1. So group 1, under group 1 or sample 1, berapa item? Let's say you have 5 item here. So the test on different or within. So di antara ni lah. Okay. The test, the differences. Okay. Itu adalah within group. Okay. So okay, this is just a example. So now kita go to sum of square total. Okay, this is a formula for sum of square total. Only use this formula to calculate total. Kalau you nak pakai formula ni susah Kan susah, dia banyak kerja. Banyak kerja. So just only use this formula. Banyak nak kira-kira ni, nampak? Okay. Okay, ni total variation SST. Macam ni, macam the idea. Kenapa dia come out dengan variation SST total. Contoh dalam data, dia untuk semua group. Let's say you have 3 group here. So, first group, you ada 3 item, 3 item. Okay, second group, you have 4 item. Third group, you have 4 item. And then, untuk semua ni, kan 4, 4, 4, 8, 11. You have 11 item N equal to 11. And then you calculate grand mean. This is grand mean. Grand mean maksudnya you sum. Value for group 1, item number 1, number 2, plus number 2, number 3, plus item 1, group 2, item 2, item 3 and so on. The last item on the group 3, you plus semua and then you cari mean. Itu adalah dipanggil sebagai grand mean. Okay, grand mean. Let's say you calculate grand mean. Value for grand mean here. Let's say lah. Okay. And then total variation, the test on the variation age of this item on the grand mean. Apa beza dia? Semua item dalam group ni dengan grand mean, perbezaan dia. Okay, this is a total variation. Okay. Okay, SSA sum of square among group. Okay, among group. This is formula for SSA. Summation C is number of group. NJ is a sample size from group J or number of item for each group. Okay, and J, X bar J mean, sample mean for group J. X bar is a grand mean, square. So what is SSA? Let's see the example SSA. Kita tengok different between group, among group. Okay. Mean group 1, mean group J. Example. So, dia nak test dia punya different ni lah. Okay. MSA is a mean square among group. MSA is a mean square among group. So you compute MSA by dividing SSA on the degree of freedom. There's a degree of freedom. Dividing the SSA with the degree of freedom. So this is a degree of freedom for among C minus 1. So it's a among group variation, SSA. So let's say Group 1, you have 3 items. Group 2, you have 4 items. Group 3, you have 4 items. So each group, you calculate mean. So X bar 1 is a mean for group 1. X bar 2, mean for group 2. X bar 3 is mean for group 3. And then you, SSA, you compute or you measure the variation among groups by dividing the, by subtract the mean for each group with the item. Maksudnya you tengok perbezaan mean dengan nilai item-item dalam group ni. Okay. Itu adalah among group variation. And then you tengok beza dia dengan grand mean. Mean untuk group 1 dibezakan dengan grand mean. Mean group 2 dibezakan grand mean. Mean group 3 dibezakan dengan grand mean. So SSW, this is a formula for SSW within group. Ada 2 summation sebab dia tengok pada 2 benda. Satu pada row and column. Okay, satu pada row and column. So it's number of group and J is sample size. X bar J sample mean for group J. Xij is the observation in group J. So macam matrix. Kalau you have matrix A11, A12, A21, A22. Okay. This is a number of kira-kira ini sebagai item dalam group, and then ni sebagai group lah. Okay. Row and column. Okay. So within group variation, they test within group. The variation within group. Okay. So mean square within group, SSW divide by N minus C is the degree of freedom. Okay, so SSW. Okay, for each group, you calculate mean. And then you tengok deviation within group. So each item compare dengan mean dia. Each item compare dengan mean dia. Each item compare dengan mean dia. So this is a formula. Okay, and then you calculate the mean square. Dividing the various sum of degree by their associated degree of freedom. Sum of square by their associated degree of freedom. So MSA, SSA over the degree of freedom. MSW, SSW over the degree of freedom. MST over the degree of freedom. Kenapa kena ada degree of freedom? Because our sample kecil, tak besar. Itu ANOVA. Kalau kita pakai sample, kita assume sample kita normal dan kecil, sebab tu dia kena ada degree of freedom. So degree of freedom for MSA, C minus 1, MSW, N minus C, MST, N minus 1. And then this ANOVA table. ANOVA table, kena tahu macam mana nak dapatkan ANOVA table. Sekejap, saya nak stop ni.